Animal Conservation Seminar Series hosted by Department of Wildlife and Fishery Sciences. I'm Rose Wang. On behalf of the seminar committee, it is my honor and pleasure to introduce our first speaker, Dr. Becky Epanchin-Niell. Becky received her BS at Stanford University, 2 masters in biology and applied economics and statistics at University of Nevada. And then she received her PhD in agriculture and resource economics at UC Davis, where she stayed on to work as a postdoc for a year. She then joined Resources for the Future in Washington, D.C. in 2010, and currently holds the title of Fellow with tenure. In the past 7 years, she has 22 papers published in Ecology Letters, Frontiers in Ecology and the Environment, Conservation Biology, Environmental Science and Policy, and so forth. Becky's research focuses on ecosystem management, particularly understanding how human behavior affects ecological resources and identifying strategies to improve management. Much of her work has focused on invasive species, including strategies to control established invaders, improvement of monitoring strategies and management. She also examines the role of restoration for reduce long-term fire threat and management costs in the western United States, and then effect of rural residential development on plants and animals. So now, let's welcome Becky to let us learn more about her research.
Hi there, everyone. Thanks for the wonderful introduction, Rose. I just want to start off by thanking you. I've had a really great couple days here already. Really appreciate the hospitality and the great conversations and hearing about everybody's research here. It's been really fun. Had never been to College Station before, and I've had a great time so far. So, as Rose mentioned, or Dr. Wang as mentioned, I've been doing work at the intersection of ecology and economics. I sometimes play my ecologist card when that seems most useful, and sometimes I play my resource economist card, depending upon where I'm at. But really, I work at the intersection of these 2 disciplines, and hopefully I can provide a little, I'm not sure what folks' background is in terms of the role of economics and conservation, but hopefully I can entice you, those who have not yet seen the light. I thought once thought economics was the evil of the world, and now use it as a tool for achieving environmental conservation outcomes. And so hope to share a bit of that with you guys today. So, should have tested out my arrows here. I've done work in the areas of conservation, ecosystem services, and invasive species management, but the bulk of my research has been largely from when as an ecologist to more of a resource economist, been focusing on invasive species management, which I'll be talking about today. So I'm going to start off with a bit of a policy definition for invasive species that I'm using. I'm thinking about the subset of alien species whose introduction does or is likely to cause economic or environmental harm or harm to human health. And this is actually definitions that were put out by the National Invasive Species Council under executive orders from Clinton and then reaffirmed last month by Obama. Invasive species, most of the folks in this room care a lot about them because of the impacts that they can have on native species. The invasive species have been found to be a primary threat to more than 3/4 of the species that are listed as threatened or endangered under the U.S. Endangered Species Act. And they're also responsible for a significant portion of vertebrate species extinctions that have occurred. On an economic context, there's different numbers that have been developed for thinking about what the magnitude of the economic impacts are from invasive species. A number that has been provided includes $138 billion per year in estimated impacts to economic, environmental, and human health costs in the United States alone. So this is a big problem. We care about it from an economic perspective, from an ecological perspective, and the challenge continues to grow. These are some figures pulled from different systems, from species accumulations in the US to Europe, Great Lakes, San Francisco Bay. So the number of introductions are increasing over time, largely driven by globalization, by the movement of goods and people around the country. And the amount of trade that we have is increasing over time. This figure on the left is agricultural imports into the US over the past, say, 14 years. And then we have world air passenger travel. So these are increasing. And while we might be depleting certain pools of potential invaders, we continue to change who we're trading with, what regions of the world we're interacting with. And so we're both increasing the amount of movement of goods and people and also the diversity of where they're coming from. So we have a lot of species exchange going on. What is the role of economics in thinking about invasive species? Invasion is useful for both understanding the process of invasions, the drivers of invasion, the impacts of invasions, and how we might think about designing policies or implementing management to control invasive species. And so we can think about the activities there. On the left, those are some of the drivers of invasive species, as well as some of the representations of some of the benefits we gain from both our economic and our ecological systems, and some of the invaders that we might think about. So a particular challenge arises because of some of the public good aspects and the external costs associated with invasive species. So most invasive species aren't introduced because somebody wants to bring a bad species to, a species that's going to disrupt a system. It's a sort of a side effect of other ongoing processes. So we have trade that's going on, and species might, there might be emerald ash borer in the wood packaging material introduced into locations. And when somebody's making decisions about trade, not necessarily accounting for the potential costs associated with the invaders that could be coming in through trade. So we can think about recreational boating. You're out there enjoying boating, you move to the next lake, and you might be bringing quagga mussel with you. Similarly, passenger travel. It's frequently finding that people bring back a lemon tree in their suitcase or even just some fruit, and that there can be pathogens or diseases on those. Citrus greening, I don't know how many of you guys have heard, I think it's impacting Texas, but it's decimating the citrus industry in Florida. And this is believed to have come in on fruit in passenger baggage. We have aquarium trade. You're done with your aquarium and you decide to release the fish, or somehow you're ending up introducing lionfish into the Caribbean. And then also something as simple as you go out camping and you're bringing firewood from one place to another, or you're taking wood up to your cabin, and that you can be moving things like Gypsy moth around. So how do we think about better accounting for the costs associated with these activities in terms of the species that might be being brought along with these otherwise perhaps beneficial or benign activities? How can we design policies to internalize these external costs associated with these different activities? So how can we design policies where we're accounting for the fact that boating could be moving mussels around? So we can think about this in each of these different contexts. So what are the types of economic questions one might ask in the context of invasive species? I think the one that most people think of economists as primarily addressing is, what is the economic magnitude of the problem? What is the dollar value that we can put on the impacts of invasive species? There's actually a need for this. A lot of people want to go to, say, Congress and say, this is a big deal, look at the dollar value. But there's a lot of other things that economics can contribute to thinking about the management of invasive species. How can we think about the budgets that we do have for managing invasions? How can we think about using the most cost effectively to protect our natural systems, protect the services they provide? Also, how much invasion management is appropriate? How big should those budgets be when you're thinking about the way in which you're trying to think about trading off resources across different species, different locations, entirely different conservation activities? And how should policies or incentives be designed to best benefit society? So thinking about the benefits, the trade-offs involved with any given policy. Typically you put in, if you're doing management, you're spending resources to get a certain outcome. And the more you spend, the better the outcome you might get. But you also can think about policies you might put in place. There's generally winners or losers. So you're thinking about trade-offs. What are the trade-offs of any policy you put in place? And how do you figure out what that sweet spot is in terms of trying to get the best outcome? So in the context that I work on, this generally requires integrated ecological and economic models. So bioeconomic modeling. So most of what I'm doing is bringing together mathematical models that might have some representation of species spread or species arrival, and then some sort of economic model that might have to do with human behavior or simply thinking about how costs can affect the management of the species. While most of my work is in the form of mathematical equations, you guys probably won't actually see any of my presentation. I'm going to just simply try to talk through some of the ways, approaches that I've used to address different invasive species management problems and talk about it more conceptually than actually digging into the math. So some of you may be disappointed, but others of you might be pleased by that. So hopefully I hit a smooth middle line there. So you can think about managing threats to invasive species along each of the stages of the invasion. So we have arrival, establishment, spread, and eventually saturation of the new potential range of an invasive species. So you can think about installing interventions along any of these different stages of an invasion. So we can think about prevention. This can be quarantine activities. This can be thinking about putting bans on particular imports or treatment of imports before they come in to domestic areas. Or we can think about inspection of goods coming into the country and how we might be able to prevent the introduction of invasive species that way. We can think about early detection and eradication. Once a species is here, what can we do about it? If we can detect it early, we might be able to either control it or eradicate it and eliminate the damages from that species in perpetuity. So how do we think about designing surveillance or eradication and control programs? Once an invasion is established and spreading, it may not be feasible or cost effective to do eradication at that point. What are the other control options we have at hand? We can think about policies to slow the spread of the invasion. And this is able to prolong the benefits in the uninvaded range prior to the invasion reaching those places. So there's benefits to delaying invasion even if you can't prevent it in perpetuity. And you can do this through things such as domestic quarantine. You can think about, they have put in policies where preventing movement of firewood across county boundaries or from infested areas to uninfested areas. These are all means to be able to slow the spread of an invasive species. And we also can think, once the species is present, you can think about trying to mitigate the damages, reduce the damages through suppression, biological control, or adaptation. Agriculturalists might change what they're growing or change the timing of their growing patterns to try to reduce the impacts. So there's different ways to think about controls or interventions along each of these stages. So what I'm going to do is talk through a couple examples, one from each of the first three stages here, just to give a sense of some of the types of economic analysis I've applied thinking about interventions along these invasion stages. So I'm going to start by talking a little bit about prevention. And specifically thinking about designing policies to prevent pest introduction on live plant imports. I don't know, how many of you guys have gone to a store in the past year and bought a plant? All right. Chances are some proportion of those plants were grown at least part of their life overseas. We grow them overseas because you don't require heating in the greenhouses, labor is cheaper, and it ends up being that off-seas production of live plants is a really key input to the domestic horticultural industry. All the lucky bamboo you buy at IKEA, I don't know if you buy IKEA here, or most of the plants you buy at Home Depot, especially, those are grown offshore. And the amount of plants that we're importing have been growing rapidly over time, with a little dip at the reception during the recession when nobody was buying plants. But we import over 2.5 billion plants annually into the US. And unfortunately, this is also a primary pathway for invasive species introduction, particularly insects, arthropods, and pathogens. So this is a figure from works from some of my colleagues showing the primary pathways for invasive forest pest introduction. So looking at pathogens, wood and phloem feeders, which are bark beetles and wood borers, foliage feeders, sap feeders. And the green here is the species that are most likely to have been introduced on live plant imports. So with the exception of wood borers and bark beetles that primarily come in on wood packaging material or other wood products, these other species, the primary pathway is believed to be live plants. So this is an important pathway to think about addressing, and some examples of species that have actually come in to the US in this pathway include sudden oak death, light brown apple moth, citrus longhorn beetle, and white pine blister rust, some of which you guys may have heard of. So we wanted to address this challenge. And there's actually been a lot of folks that have called, we need to ban the importation of all live plants. So focusing on the costs associated with importation from invasive pest introduction. Obviously, there's a lot of pushback from both consumers who enjoy the diversity and the cost of the plants that we get, but also the horticultural industry, of course, gains a lot of benefits from importation of live plants. So we ended up putting together a working group out of SSINC, which is the National Socio-Environmental Synthesis Center. Cool. I definitely recommend checking out if you're interested in integrative research, social ecological research. But we brought together entomologists, plant pathologists, and economists and entomologists. So all of these together, along with representatives from USDA APHIS, which is the Animal Plant Health Inspection Service. They're the folks that are in charge of regulating the live plant industry in the US, and also do all the inspections of shipments of live plants that come into the US. And we brought together this group to think about how we can design more cost-effective strategies to reduce pest risk from live plant imports. And you can think about some of the different tools that might be available, or different interventions that you can think about, including import restrictions and bans on particular commodities coming in to the country. Think about pre or post-entry treatments or quarantines to try to reduce pest loads on goods. And then also inspection ends up serving as a key tool for reducing pest risk into the US. Each of these kind of feeds back, they interact with each other, and we have a number of different projects that have come out of this working group. But I'm going to talk about one, which is a little bit more on the economics-y end of things, but hopefully gives a little bit of sense of some of the tools that economic perspectives can bring to this decision, and it's focusing on inspections, so inspections at the border. So what are the goals of inspection of live plants? APHIS views it as primarily to gain information about the different commodities that are coming into the country. How do we know which ones are the riskiest? Which countries and which genera of plants are most likely to have pests that could end up causing damage within, if introduced into the US? We can think about prevention of the introduction of pests. If you can intercept the pest at the border as the shipments are coming in, then you can prevent their entry into the US. And it also serves as a deterrence mechanism. If you as an exporter know that when you send your shipment, it's going to be inspected, you're much more likely to send cleaner shipments, because you know that if your shipment's detected to have a pest, it's going to be destroyed, it's going to be sent back, or perhaps just treated, but either of those ways, you're losing significant economic value from the things that you've shipped. So in the United States, there's 17 plant inspection stations, and all of the live plant imports come through one of these different stations. And there's inspectors at hand, and they're going through and literally opening up boxes of plants and looking at the plants for any signs of pests or disease. And if a shipment, each shipment's inspected, and if they find any signs of pest or disease, if it's one of the regulated pests, something that we don't already have here, then the shipment's going to be treated, rejected, or destroyed to prevent the entry of those pests. Not surprisingly, if we have over 2 billion plants coming into the US annually, we don't have currently the inspection capacity to exhaustively sample all of the shipments coming in. And so how can we think about allocating the resources that we do have for inspections at the border to do a better job of intercepting the shipments and preventing the acceptance of infested shipments into the US, where they could then go on to cause ecological and economic harm? And during this work with this group, we were working with USDA APHIS, and this is something that they're really thinking hard about. Currently, at the time, they had a rule, essentially guidelines for each inspector. Inspect about 2% of each shipment coming in. And that was essentially the guidance that was being given. And there's a recognition that you really ought to be targeting the riskier goods more intensively than the less risky goods, because you're more likely to be able to keep stuff out. And so they've been thinking about moving and shifting to a risk-based inspection system, where you target the riskier shipments, but also putting a particular framework on this, where they're thinking about categorizing exporters into, say, high medium, and low-risk groups based upon their history of interceptions of shipments coming in. So whoever's been sending the dirtiest stuff is going to be in the highest risk group, and whatever has the least dirty is going to be in the lowest risk group. The other thing about this is you can move between these groups based upon so if you clean up, you might be able to move to the lower risk group. So what they're considering is shifting from a uniform inspection policy, where say you have the higher risk groups, the things that have a worse interception history, or the lower risk groups. Currently, it's more or less an even inspection intensity across each of these different groups of shippers. And the idea is to shift some of that inspection intensity to the higher risk groups. So when thinking about a policy shift like this, there's a lot of questions to answer. How do we decide what the cutoff should be to define a high risk, medium, low risk group? You know, how big should each of these groups be, and how should the inspection intensity differ between these groups? How much more effort should we be putting on the high risk versus the low risk group? Secondly, if you're thinking about making a big policy shift like this, what are the potential gains? Is it worthwhile, given that there's a lot of institutional costs of shifting a structure like this? And so we just had this come out last month in Journal of Economic Behavior and Organization, and my guess is, with the exception of maybe one person in this room, nobody else would actually want to read this paper, but we actually have some cool lay policy papers tied to this, because we're really wanting to communicate the outcomes of this to folks at APHIS and elsewhere, and other stakeholders who are going to be facing a policy change like this. So what we did was develop an economic model. And an economic model has essentially two decision makers in it. Well, actually, it's many, many decision makers, but there's a whole bunch of exporters and one regulator. And the regulator is choosing what should these cutoffs be to define, high and medium risk groups of exporters, and how much should you be inspecting one versus the other. And their goal, the regulator's goal, is to minimize the number of infested shipments that are accepted into the US. As they make that decision and set that policy, are trying to anticipate what the exporters are going to do. So embedded in their decision is the response of the exporters to the policy. So what do the exporters want to do? They're choosing how much they're going to abate the pests on their plants. Like, how much effort are they going to put into cleaning up the plants and making sure they're sending clean shipments to the US, which has a cost associated with it. And their objective is to minimize their long-term costs from cleaning up their shipments, from being inspected. So even incurring an inspection poses a cost on the shippers, because it ends up delaying the movement of the shipments from to the eventual consumer. And we can have degradation of plants during that time. So they don't actually like being inspected for that reason, but they especially don't like being inspected if it's going to end up posing a cost because your shipment is destroyed or rejected because a pest is found on it. So you have the objective of minimizing the acceptance of infested shipments and the objective of minimizing long-term costs. And so we end up developing a model that embeds these different decisions. And what we find is that under a risk-based inspection model relative to uniform inspection, that both the high risk group and the medium risk group actually end up being cleaner. They do cleaner than under a uniform policy. So they both end up investing more in cleaning up their shipments. And the reason for this is actually fairly intuitive. The folks in the high risk group end up abating more because they're being inspected more, so they're going to have more interceptions and thus more shipments being destroyed. But they also really want to get into that low risk group, so they aren't inspected as often. So they're trying to clean up to be able to move to that low risk group. And meanwhile, the folks who are in the low risk group, they don't want to get moved over to that high risk group. So they're abating more in order to be able to stay there. And so what we end up finding is that policy just simply shifting, same amount of resources going into inspection, shifting from a uniform policy to a risk-based inspection policy can reduce the number of accepted infested shipments by 20%, just by reallocating existing resources. And so this is really helpful as APHIS is trying to make decisions about this process, and also to be able to justify the policy change to all of its stakeholders. And so this has been a pretty fun project, getting to actually work with the folks who are going to be thinking about implementing this policy. So, moving on, the next component that I was wanting to talk about is thinking about the early detection and eradication. So we weren't successful at preventing the introduction, and now we're thinking about how we might be able to minimize the long-term impacts through surveillance and early detection. So the goals of surveillance, what I'm thinking about here, is there's a lot of programs done by Forest Service, by APHIS, and other state agencies where they're actually placing traps or doing surveys out on the landscape for early detection of invasive species in order to be able to control or eradicate those species. The idea is that the earlier you're able to detect them, the less costly the control is going to be, the more likely you are to be successful. And in the literature, there's various different approaches for thinking about optimal surveillance. In the ground, on reality, sometimes these are traps or surveillance is allocated based upon proxies for likelihood of introduction. There's, in the literature, focusing on achieving a given probability of detection. When thinking about large budget allocations, this is often done in a much more ad hoc fashion, where either it's what states need funding for Gypsy moth surveys. Okay, let's split it evenly between the 12 states that need it, or what has been your historical allocation. So there's not been necessarily a whole lot of economic justification, at least formal justification, for how these resources are being used. And so what we've done here is develop a bioeconomic model to try to think how we can minimize the long-term costs and damages from invasions, accounting for the cost of surveillance, the cost of control, and the damages posed by invaders. So the key thing here is that there's this trade-off. Trade-off between investments in surveillance. The more you invest there, the earlier you're likely to detect. But there's some sort of balance here. This is illustrated, can be illustrated with this figure here, where you can think about the density of survey points in a given landscape, and then this is the cost. And you can see this green line here is the costs of surveys. Increases the more surveys you're putting out, you have increasing costs. And this is the cost of eradication, or you can think about it as eradication, control, and damages. And then the more survey you're doing, the earlier you're going to detect species, and the costs are going to be lower. And so you sum those together, and you can get your total cost as a function of the density of survey points, and you're going to want to choose the minimum spot along that curve. And that would be your optimal survey points. But how would you get there? What we've done is develop a bioeconomic modeling approach. We've actually then been adapting and applying it to different systems as the needs have arisen. And I'll talk about a couple of the examples. I want to talk conceptually about the model that we developed to try to address this question. So what we think about is that we divide the landscape into a whole bunch of different focal management regions. You can think about these as different sort of relatively homogeneous areas where you might have similar rates of introduction or similar risk factors, or maybe it's just your smallest available mapping unit. But you can think about an establishment rate, a background rate at which new invaders might establish within each location. And once a population establishes on the landscape, it can grow over time and at some background rate. We model this as an size class model, so very much like an age class model, where you have populations moving from one age class to another over time. But these populations can be detected through surveillance effort. So what we think about is, what is the density? We measure this as the density of samples or surveys on the landscape. And then the probability of detecting any population that might be out there in the landscape is going to depend upon the size of the population, how many traps you've put out there, as well as the effectiveness of those traps. Things like gypsy moth lures, their use of pheromone, very effective. Then you have a lot of bark beetle traps or visual surveys that have much lower detection effectiveness. So you can bring this in and then model the detection probability as a Poisson process and incorporate that into this size class model. Following detection, you can attempt eradication. And so, once this population is detected, you attempt eradication, and the cost of eradicating the population is going to depend upon the size of the population. Cheaper to eradicate smaller populations, more expensive to eradicate larger, but also the probability of being successful at eradication also tends to decrease with increasing population size. And what we actually, in some of the models that we do, we embed this decision of whether or not to attempt eradication into the model, where a decision maker is going to consider both the costs of attempting eradication and its probability of success, and what would happen if you didn't attempt eradication at all, and make that decision whether or not that's even worthwhile or whether some other control option would be needed. So you set this up, and what the overall goal is to then choose what your optimal sampling density is in order to minimize the cost of surveillance, plus the cost of eradication, and the cost of damages, where these two depend upon your investment in surveillance, because that affects the timing of your detection. And we can sum this across different invaders, and then we can also sum these total costs across the landscape, so each individual focal area across the landscape. We've done this in some cases at the 10K grid cell scale, and then others at the county level. So I'm just going to quickly just show the results from two of our applications. This was the paper where we first developed this model, and we applied it in the context of Gypsy moth and European Gypsy moth. European Gypsy moth is established in the northeastern US, and it ends up leading to massive defoliation of forests. Everybody here does not want Gypsy moth. And so there's actually substantial survey programs elsewhere in the US to try to detect populations of this invasive species earlier. They're often brought in with moving trucks or people moving across the country, and so we end up with detection programs. How would one design detection programs in these different states, these different locations, to minimize the long-term costs, accounting for probabilities of introduction and the costs of control? And so we ended up applying this in the state of California. We had parameterized used historic data on establishments, as well as information about how costs vary across the landscape for surveillance, and used that information, that heterogeneity in costs and establishment, to determine how traps should optimally be established across counties in California. And one of the things that we're able to show is, what is the expected cost and damages under a uniform inspection program versus a variable trapping program where you're actually optimizing based upon these different characteristics. And you see substantial reduction both in terms of the number of traps that are needed and the costs of controlling invasions as they're found. So after doing this work, and that I would have considered more, the county level scale of results is not that useful for on-the-ground management, might be useful for thinking about budget allocations. So I was quite excited when folks from New Zealand came and said, hey, this model, we think this is really useful for thinking about whether we should be implementing a wood borer bark beetle surveillance program in New Zealand. They have a huge plantation forest. Timber exports are a very important economic sector for them. They have natural forests, a lot of urban trees, and they currently had no trapping program in place. And so what we did was think about applying this model in the context of New Zealand. We needed to expand it to consider a whole bunch of different species, which we considered different types of potential invaders, and then looked across 4 different ports in New Zealand, the distribution of resources relative to those ports, the relative introduction rates across those ports, and then we're able to solve for what is the optimal level of surveillance across these locations. And this just summarizes across the entire New Zealand. This is looking at the total number of traps you put out, and this is the expected net benefits. So what is the benefits of implementing a given level of trapping compared to not doing any trapping at all? As you can see, the benefits increase rapidly with initial investments in trapping and then flatten off. And so while the optimal level of surveillance is really high, you're getting pretty far even by just putting in some amount of a surveillance program. And so currently I'm not engaged as much on the policy front on this, but I have colleagues in New Zealand who are working to try to think about how a program like this might get implemented. So I'm going to move on and talk about the final aspect that I'm going to touch on today. And this is thinking about, okay, you've missed eradicating the population. You have populations spreading across the landscape. What are some of the strategies that we can put in place? So, getting at this, the key feature of invasions, they spread. They spread over time, they spread over space, and as a result, they end up impacting larger and larger areas over time until they've expanded and reached their new range boundaries. So this means that damages are increasing quadratically or exponentially over time. And the second feature of it is that means they're also spreading across jurisdictional boundaries. So decision maker, depending upon where the invasion is reached, there's different decision makers involved in making choices about invasion management. And so, with respect to the first component of this, there's been a lot of work thinking about how much control you would want to do for an invasion, depending upon how big it is, how fast it's spreading, costs and damages. I'm not going to present that work here today, but we can think about this optimal intensity of control, and we can, typically early on in an invasion, it might be optimal to eradicate. As the invasion occurs across a larger proportion of the landscape, policy often switches to slow the spread, and then eventually the optimal policy is actually to abandon control in some cases, because there's not enough area, uninvaded area on the landscape remaining that's worthwhile to protect or to prevent the invasion. Instead, you might switch to other adaptation or suppression methods. We can also think about where on the landscape we should be applying controls, and how does this depend upon where resources at risk occur, how big the landscape is, what is the likely patterns of spread across the landscape, and how do invasion and landscape characteristics affect optimal control. And I think this is really cool, and I was hoping to talk about this, but I decided to spare you guys. So instead I'm going to talk about the last portion of this, which is really focusing on this jurisdictional component, where trying to understand what happens if you have a bunch of different decision makers on the landscape, different landowners, different counties, different states, making decisions about invasions. How does the result of that sort of bottom-up management of invasions compare to if you're having a top-down manager thinking about what is the socio-optimal thing to do across the entire landscape? And so this work that I'm going to be describing is work that I did with Jim Weiland, a resource economist at UC Davis, actually my graduate advisor. And it was actually motivated by some work that I did in grad school, some collaborative work that I did with other graduate students, in which we decided to go out and interview ranchers across the state of California to try to understand what factors are affecting their decisions about whether or not to control yellow star thistle on their properties. So yellow star thistle is a spiky plant that cows do not like to eat, and have a lot of impacts upon ecosystem services. There are well-known control methods out there. Why is yellow star thistle continuing to spread and be a problem? And so we went out and we interviewed ranchers, we did surveys. But one of the things that came out of it, besides simply the cost of control and some other practical issues, 68% of the ranchers said there was a need for coordinated control effort. They often controlled less because the invasion was spreading from the neighbor's land. What we found is that ranchers responded to neighboring invasions either by controlling less, being like, I give up, it just keeps coming in no matter what I do, this is hopeless. Stopping the spread at the property boundary, like literally going out and pulling out plants each year as they come across the fence. Others actually hopped the fence and were controlling on their neighbor's land or on their roads. Some of them said that actually didn't make people very happy. But others actually developed a cooperative strategy. They got together and they said, hey, let's control this together, went out and hired a contractor or coordinated their management to ensure that everything was being treated in a coordinated fashion. So this actually motivated the modeling work that I eventually did. So what I want you to think about, say this is the potential range of yellow star thistle spreading across the landscape. And as the invasion is spreading, if I were a regulator or a manager coming in, and this was my whole range to think about how to manage, I might say, oh, we need to eradicate this, or we need to slow the spread, or we need to stop it. Totally different situation if you suddenly think about this spreading in a landscape mosaic. And suddenly, this landowner is making decisions about whether or not to control the invasion based upon the costs and benefits that that landowner faces, not necessarily accounting for the impacts that the invader will have as it spreads to the neighboring lands. And so you expect that there might be very different management outcomes from this bottom-up management versus a top-down management. So what are some of the focal issues that arise in these multi-manager landscapes? One is actually kind of more of an ecological question. How do private control decisions affect invasion spread? We think about invasion spread as a natural process, local dispersal. We think about long distance dispersal where people are moving things around on boats, on goods, on firewood. But then humans actually play a role also in terms of slowing the spread or containing it or controlling invasions. So how might that play out? And how do aspects of the bioeconomic system, the costs and damages faced by landowners, the spread rates of these species, affect the difference between what would happen under private management versus a top-down management of the species? And how well might cooperation, so this collaboration among landowners on the landscape, help to move from perhaps more of a under-controlled situation more towards an optimally controlled situation? And what policies might you be able to implement to try to encourage that reaching more for an optimal, socially optimal solution versus what might arise under a bottom-up policy? So the model that we use to begin addressing this is actually a fairly simple-looking model. If you think about a gridded landscape, where each cell in the landscape can be invaded or uninvaded. In this case, we're thinking about each grid cell being an individual parcel. So there's an individual decision maker governing the decisions of invasion management in each of these parcels. And the invasion can spread across the landscape to adjacent parcels in the absence of control. So this is essentially a SIS model, susceptible, infected, susceptible model, depending upon control, where you have the invasion spreading in the landscape in the absence of control. But there's control options that are available to land managers. This manager here could choose to apply controls at its border to try to prevent the spread of the invasion onto its property. Or if your parcel is invaded, you could choose to invest in clearing that invasion. Each landowner in the landscape, we assume, is trying to minimize his long-term costs and damages, accounting for the damages that he'd incur over time for as long as his parcel is invaded, as well as the cost of controlling, either the long-term cost of preventing spread onto the property or the cost of clearing and making sure the parcel remains cleared. So what we then wanted to do is think about consider three types of bottom-up management, where what happens if each individual in the landscape makes their decisions based upon only their own costs and damages without any coordination, negotiation, or interaction with their neighbors, but accounting for potential invasion spread onto their property. Then we could also think about what if these landowners could engage in sort of a invasive species management club, where each individual in this club were willing to contribute their own willingness to pay to control the invasive species. So this person here is willing to pay to control the invasion or perhaps eradicate it over here, whatever they think the cost would be that they'd incur, if this invasion weren't controlled and they're having to prevent it in perpetuity, for example. So how much control could you get if each person were willing to contribute to control? And then what if you think about expanding to a broader neighborhood? So if you were to eradicate this population over here, that's actually providing benefits to this parcel, this parcel, this parcel, because otherwise the invasion would eventually spread to them, and they'd either have to control or incur those damages. So what we want to do then is we simulate these different bottom-up decision frameworks, and then we want to compare it to what a social planner would do. If there's somebody managing the entire landscape to account for costs and damages across the whole landscape, what would be the solution, and how different are those? So I'm going to just show one figure in two parts about one of the cool outcomes that I thought it was cool that came out of looking at this. What this is we're looking at, imagine a 15 by 15 parcel landscape. An invasion starts in the center of that landscape, and we're thinking about what are the benefits of containing that invasion in perpetuity. And so along this y-axis, this is the benefits of preventing the spread of that invasion in perpetuity. And this is saying for that invasion, how would those benefits differ depending upon how much it cost to prevent spread into the neighboring parcel? So as the cost of control increase, the gains from containment are going to decrease because the benefits depend upon your avoided costs your avoided damages minus the costs. So essentially, if you say the damages are, if you allow the invasion to spread, the damages would be $100, and it costs a certain amount to control. The difference between those is your benefits. But But if the costs of control increase, then essentially your gains from control get smaller because you're not making as much returns on that investment. So what you see is the costs increase, your returns from that investment are decreasing. If you then look and say, well, how much cooperation, how expansive would that club need to be, or that coordination across the landscape, in order to achieve successful containment of that invasion, and how does that depend upon the costs of invasion? You know, the more costly it is to control it, you're needing more individuals to be willing to contribute to control of that invasion. So you actually need greater amounts of coordination the higher the costs are. And so when you put these two together, one of the neat things that you see is that in the cases where, you know, all else equal about the invasion, when the control costs are such that there's the greatest returns from successfully controlling the invasion, that's actually when you need the least amount of coordination. And thus might be most likely to be successful at achieving coordinated management of an invasive species, you know, all else equal about that invader. And I found this neat because, you know, this really provides some information about the potential gains, the benefits to society that can be provided even by private management of invasive species, and in particular by if you're able to encourage cooperative control. And then you can start to think, some of the next steps would be thinking about how different control incentives might be able to enhance this private contribution to the public good of invasion control. You know, either by increasing the incentives to each individual landowner to want to contribute to control, or by removing barriers to cooperation. How do you incentivize that cooperation? So you can think about subsidies, fines, taxes. All of those things might encourage a greater level of private investment in control. Education about control. In some of the cases of the ranchers, they might not know the appropriate control methods, or they might not realize how damaging a species is until they're already experiencing it. So in some cases, education might even be successful at helping to increase private management. But also any sort of institutions that can help reduce the transaction costs that allow this bottom-up management and coordination. And things like weed management areas. There's a lot of these in California. Oftentimes it's mostly among federal agencies, but also bringing more of that type of organization that facilitates coordination in the case of private invasion management. So, you know, what I've done is try to kind of lay out a couple of examples of the way it can bring bioeconomic analysis to informing invasion management at each of these different stages. And in reality, though, you know, this is, we view this as the safeguarding continuum, what it's often referred to. And in reality, what you choose to do in investments or policies you put in place at any given place along this continuum have impacts upon what policies would be optimal elsewhere. If there's nothing that you can do once a species is introduced and it's likely to be highly damaging, that has implications for how much prevention effort you want. But there's also each species can come in along multiple pathways and mostly governed by different policies, and you also have interactions between different species. So thinking more holistically, bringing these together in a more holistic framework, systems-oriented modeling is some of the next steps, some of the current work that's going on. So the final remarks that I want to leave you with is, you know, what I'm hoping to have shared is the ways in which economics can provide some tools for designing cost-efficient invasion policy and management, and highlighting some of the policy trade-offs. Sometimes it's very easy to look at the impacts of a particular action and say, oh, we need to ban that action, but often there's trade-offs involved, and how do we think about those and more clearly elucidate what those trade-offs are. And also how one might design incentives to ensure that you're getting the outcome that you want and also avoid any unintended consequences. You know, for example, bans on live plant imports might lead to a higher amount of smuggling, which then tends to bring in dirtier things. You need to think about these as a more systems-oriented thing. And I feel, at least in my work, it's been really helpful to bring in collaboration across disciplines and also engaging stakeholders, engaging policymakers, and engaging the folks that are either doing the management on the ground. It just has really helped me to understand the systems and also make it so that my research is better able to feed into the decision making. And I also am finding with my interactions with agencies, there's an increasing demand in general, recognition of the role that economics can play. Just as resources become scarcer and scarcer, there's much more recognition that we need to think about how we can get the biggest bang for a buck with the things that we do. And so with that, I want to thank funders for various aspects of this work, my many co-authors and colleagues that contributed to all of that work that I shared here today. All of it was collaborative. Many thanks to the Department of Wildlife and Fisheries Sciences for having me here, and especially to Dr. Rose Wang for the invitation. It's been really great, so thank you. And if anybody has any questions, I'd be happy to answer them.
Hey, we talked about a little bit about what I'm going to ask yesterday, but how a citizen or an entity can approach your organization to know more about, how to manage invasive species, for example.
So specifically with my organization, so I'm at Resources for the Future, and it's an environmental policy research institution. So very much like an academic position, except for that we're supposed to do policy outreach. But as a result, with pretty much every publication that we do, or any research that we do, we try not only to have a journal publication, but we try to either have a blog about, to explain in more lay language what the importance is of that particular research to management, or different other, we have public events often associated with those. But also I've actually gotten phone calls. I did some work on the USA, and I actually had landowners. I did a webinar or a seminar on this, and I had landowners calling me up and asking me about some of the programs under these. So it's, I guess, different ways to engage. But the idea is try to translate some of the more technical work into what are the key points that would be more relevant for different audiences, but also just talking. A lot of it's been going and talking with people to try to meet in the common ground.
I was wondering if you could share a couple of thoughts about what you thought about with scenarios where an invasive species has a profound effect on biodiversity, but those effects are not economically important in markets.
Yeah, I think that's actually the big lack. That one of the things that people are working on and is currently underrepresented in a lot of the economic analysis is that measurement of biodiversity. So like a lot of the work that I did, I'm choosing different damage categories. Oftentimes, when possible, I try to also include some sort of biodiversity measure, not in economic dollars, but that's not always feasible. And so an important part of communicating the outcomes is the recognition of what the gaps in the analysis are and what the implications of those gaps actually are for policy. So in all of the work that I've done on the surveys, I've been looking at urban impacts and timber harvest impacts, and there currently isn't biodiversity impacts per se in that, which is a huge gap, and that's something that always takes up half the conclusions, because that would all lead to wanting to increase the amount of investments that would be in surveillance. So there are folks working on that, trying to do that, but I don't know, it's not I think there's a big push to put dollar values on things, because so often in like agencies and elsewhere, there's a cost-benefit analysis that's helping to inform decisions, and if nothing's in there, it's often implicitly given a dollar value. But many things are not possible, so just making sure that it has a line and putting in whatever quantitative measures, biophysical, biodiversity measures are possible, that is really important, and I think there's a much bigger push to be doing that, but there's a long ways to go. Sort of a long-winded answer, and not a very satisfactory answer, so sorry.
I appreciate the thoughts.
So in terms of your work with on detection and eradication, these models, so in order to sort of solve that optimization model, you got to have really good biophysical models in terms of spread and probabilities and things like that. Do you find that that you're able to just sort of draw, go to the literature and pull off the shelf the right parameters, or is it rather a sort sort of a shift in focus entirely for the natural scientists as well in terms of how they do their research in order to parameterize the model in a policy relevant way.
Yes, the latter, yeah. The biggest challenges most often that I've faced with doing a lot of this modeling when you're actually trying to apply it to a real system is the actual parameterization of the models. That is by far where the bulk of the collaboration comes in and the bulk of the time comes in, because those are not readily available. You think about, even for species where we have lots of observations, so introduction of European gypsy moth into the western US, we actually have a lot of data on establishment. That's a well-studied system, so by far the most well-studied of the systems that I've looked at. And even there's a lot of effort trying to estimate variable establishment rates across the landscape. That wasn't already done. But then you think about spread rates, and we know so little about spread rates because when you observe a population, you don't know how long it's been there. And so, no, you're ending up having to do incredible amounts of either incorporating that uncertainty into the modeling framework or lots of sensitivity analysis to understand how robust your decisions are to those assumptions. But then, I've been doing some recent work with APHIS on wood borer bark beetle introduction for species that have never yet established in the US. And I've actually been drawing on some ecological models that have been linking establishment rates to propagule pressure tied to trade for the broader wood borer bark beetle group, and using that to get estimates of overall likelihood of establishment, which is very low for the species I was looking at. 0.006 in any given year was the basic underlying estimate, with large uncertainty bounds. But that actually is a case where there's been a lot more work with trying to link propagule pressure to establishment rates, and some of that's been useful. But yeah, another huge value, economic impact of invasive species for forest insects is actually on urban trees. You think about emerald ash borer passing through cities and totally changing the character of neighborhoods, the costs of ash removal as this species totally decimates the species. Huge ecological impacts, but from some of the largest economic impacts are on residential areas. But the amount of information on the distribution of urban trees across the US, we don't have good data on that. So trying to even link some of these other things. So yeah, this is by far.
So I guess what I was asking is, does the interaction with you and your modeling actually bring up entirely new sort of natural science analysis that's needed that didn't exist or wasn't being done before?
Yes, or it highlights, yes, in that we're doing some more work, so it has inspired some ecological studies that leading, I guess, looking at, in particular, establishment rates, trying to understand spread and lags in ecological systems, lags of, but I don't know that those are necessarily new questions, but it's new ways of thinking about what the quantitative outputs or what the useful outputs of studies like that would be. Not sure if that's.
Maybe more of a statement. This morning I gave a talk to nearby county. I do a lot of work with invasive wild pigs, working with landowners. Great crowd this morning. Wild pigs cost minimally $52 million worth of agricultural damage in Texas alone, about 1.5 million nationally. Our landowners well know the problem. We're in that latter stage of having to deal with this invasion that is established. My question goes more back to the work that you do as a group. We do a great job with educating the public, and our return on the dollar for that is very high. But I'm wondering whether your group is able to make insertions of policies with our legislators to help with decisions that are being made for a management level. So I think we're lacking in that communication with the actual legislators.
Yes, and so I do my best, and I guess it's maybe not working specifically with legislator, I've been doing more with agencies, but the idea of actually communicating the results is not necessarily saying this is what you should do. I try not to advocate, but it's more, these are the policy options, or this is what a model would suggest the outcomes would be under this case relative to under this case. So trying to provide the information that can help with the decision making. I mean, in the case of wild pigs, there are folks who benefit from it. So you have winners and losers in any policy, and so being able to try to highlight you know, these are the trade-offs, these are the outcomes of a different policy. My role as a researcher, maybe me as a person I can advocate, but as a researcher I tend to try to, partly because of the institution I work at, this is our policy, is that I provide the information rather than specifically advocating for a particular policy. So that's but I think that taking that research and be able to inform the people who are actually making decisions about what science has to say about the potential outcomes is key. Otherwise, I mean, that's how I ended up where I am, is wanting to be able to do that and trying to do that more, so.
I believe some people still have questions for Becky, but it's already 1. So finally, I thank everybody for attending this seminar. And we are going to have another annual conservation seminar in March. So please stay tuned for our emails. And thank you so much. Thank you.
Thanks, everyone.